Hello and welcome. In this video, we will review another problem which states that two cards are drawn from a well-shuffled ordinary deck of 52 cards, and we want to find the probability that they are both aces. Now, there are two parts to this example. In the first example, we assume that the first card after it is drawn is replaced back in the deck. And in the second example, we assume that the first card after it is drawn is not replaced back in the deck. Let's first define our sample space. In this case, it is made up of spades, hearts, diamonds, and clubs, where each of spades, hearts, diamonds, and clubs contain 13 cards from ace to king. So there are 52 cards in this sample space. Here, we are interested in the event that the drawn card is an ace in the first attempt, and it is also an ace in the second draw. We denote this event as A. From the definition of the conditional probability, we know that the probability of A, which is the same as the probability of both A1 and A2, is equal to the probability of A1 times the probability of A2, given that A1 has already occurred. Now, in part A, the first card is replaced in the deck, so the probability of getting ace in the first draw will have no impact on the second draw, as these are independent events. Therefore, we can get the probability from the product of probabilities of both A1 and A2, which are 4 by 52 or 1 by 13 squared, which equals 1 by 169. In part B, since we are not replacing the card in the deck after the first draw, this affects our sample space. In this case, the number of possibilities of picking an ace from the deck reduced to 3 for the second draw. And since our sample space consists of 51 cards, the probability of A2 given A1 has occurred is 3 by 51. Multiplying this with the probability of A1 gives the result as 1 by 221. So the probability in part B is smaller than the probability in part A. In the next video, we will cover another problem. Please subscribe, share, and like this video. Thanks for watching and see you all in the next video.